Welcome to the peaceful space of sleep-friendly science, where tonight we drift far beyond our own world to a moon wrapped in ice, harboring a vast and mysterious secret. Our destination is Europa, one of Jupiter's most intriguing moons. Imagine a world with a fractured, frozen surface hiding an ocean deeper than any on Earth. Warmed not by sunlight, but by a hidden inner fire, we'll gently ponder the ultimate question: could life be swimming in those dark, silent waters? Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. A distant, icy jewel. And so, our journey begins not with a roar, but with a whisper, a silent letting go. You feel it as a gentle sigh passing through the vessel that cradles you, a severance from the familiar pull of home. Your body, now a feather in the quiet dark, remembers the weight of gravity, but it is a distant memory, a story from another time. Outside your viewport, you see it, Earth, our beautiful, restless, and vibrant world, now suspended in the velvet emptiness. It is a perfect marble of swirling white clouds, deep blue oceans, and the warm, brown-green tapestries of land. You watch as the city lights on the night side of the planet begin to twinkle, a final, collective wave goodbye from the shores of home. They are a constellation of human dreams, a web of light and connection. And as we drift away, they merge into a soft, singular glow. There is a profound peace in this departure, a sense of expansion, not of loss. You are not leaving, but proceeding. You are a thought, an idea, a point of consciousness gliding out into the grand, silent cathedral of space. The hum of the ship is a low, steady mantra, a sound you can feel in your bones, a constant, reassuring companion in the immense quiet. Earth continues to shrink. The familiar shapes of continents soften and blur, the intricate details dissolving into the whole. It becomes an object of pure, breathtaking beauty, a single, precious jewel hanging in the void. You see it now not as a place of borders and noise, but as a single, living organism breathing in the light of a distant star. It is a lonely, lovely miracle, and for a long, timeless moment you simply watch it, holding its image in your mind as it recedes, a pale blue candle flame flickering in an endless, dark room. We turn our focus forward toward the great expanse. The sun to our side is no longer the soft, atmospheric star we know. Here, in the vacuum, it is a fierce, brilliant diamond, its light sharp and unfiltered. It does not warm the air, for there is no air to warm. It simply is a torrent of pure energy, a gravitational anchor holding our path true. Our trajectory is a long, graceful curve, a cosmic ballet choreographed by the laws of physics. We are falling around the sun, a carefully calculated arc that will carry us out, ever outward, into the realm of the giants. The days and weeks blend into a slow, meditative rhythm. The ship is a monastery of metal and glass, floating through an eternal twilight. The stars here do not twinkle. The atmosphere that makes them dance is gone, and they burn with a steady, ancient fire. They are unimaginably numerous, a fine dust of silver and pale gold scattered across the blackness. You begin to see the universe not as a flat canvas, but in its true, three-dimensional depth. Some stars are close, their light bright and bold. Others are whispers from across impossible gulfs of time and space, their photons having traveled for millennia just to greet you on your journey. You are floating through a library of ancient light, each star a story, each galaxy a history book written in fire. We drift past the silent, ruddy glow of Mars, a sleeping ember in the cosmic hearth. Its dreams of water long since faded to dust and rust. It is a quiet neighbor, a reminder of how delicate the balance of life truly is. And then we cross a line unseen, a border drawn in dust and ancient rock. This is the Great Divide, the asteroid belt, not a chaotic jumble of stone as so often imagined, but a vast and lonely realm where the rubble of a planet that never was continues its slow, patient orbit. These are the forgotten building blocks of our solar system, cold, silent witnesses to its fiery birth. We pass through them without incident, their orbits so widely spaced that they are but lonely islands in a dark, empty sea. But crossing this threshold feels significant. It is a rite of passage. We are now officially entering the outer solar system, the domain of the gas giants, the cold, majestic kingdoms that lie far from the sun's immediate warmth. And it is here, in this new, vaster part of space, that you first see it. Our destination. At first, it is nothing more than a star. A particularly bright one, to be sure, but a star nonetheless. It does not twinkle. It holds a steady, unwavering light, a quiet declaration of its own importance. This is Jupiter. For weeks, it is merely the brightest point of light in your field of view, a beacon drawing you forward. But you know with a sense of rising awe what it is. A world so vast it could swallow every other planet in our solar system whole. A king ruling over a court of dozens of moons. Slowly, patiently, the point of light begins to swell. It blossoms in the darkness. What was once a simple pinprick now begins to show a disk, a shape. You can begin to make out color, faint bands of cream, orange, and tan. This is not the solid, rocky ground of Mars or Earth. This is a world made of cloud and storm, a churning, chaotic atmosphere thousands of miles deep. Even from this immense distance, you can feel its presence. It is not a quiet world. It is a place of unimaginable power, a behemoth of hydrogen and helium, a star that failed to ignite. And as Jupiter grows in your view, you begin to see its companions. Tiny, faint sparks of light moving in elegant, perfect orbits around their parent. These are the Galilean moons, the 4 largest of Jupiter's children, discovered by a curious human with a new kind of glass lens 4 centuries ago. Io, the volcanic and tortured. Ganymede, the largest moon in our entire solar system. Callisto, the ancient and heavily cratered. And there is the 4th. A point of light that seems smoother, paler than the others. It shines with a gentle, milky light like a pearl against the black velvet. It seems serene, placid, almost featureless from this distance. This is our true destination. This is Europa. A world that holds a secret beneath its quiet, unassuming face of ice. It calls to us, a silent invitation across the void, promising a mystery buried in an ocean of eternal night. Section 2. The Realm of the Giant. The steady hum of the ship deepens almost imperceptibly, a subtle shift in the resonant frequency that has been your companion for so long. It is the first sign that things are changing. You are no longer simply coasting through the void. You are being received. Jupiter's gravity, a force too vast to comprehend, has reached out across millions of miles of emptiness and taken hold of your small vessel. It is not a violent capture, but a gentle, inexorable pull, like a river current catching a leaf. You have entered its sphere of influence. You are now part of its system. The king has welcomed you into his court. The planet, once a distant, banded marble, now dominates your entire view. It is no longer a planet. It is a universe of its own. It fills your window, a breathtaking, terrifying, and utterly beautiful vista of unimaginable scale. You are a mote of dust floating before a masterpiece painted by a chaotic god. The bands of color are not simple stripes, they are immense jet streams, rivers of cloud and chemical haze, each one wider than our entire Earth. Pale zones of rising ammonia ice crystals flow alongside deep, rust-colored belts where the atmosphere is sinking. They flow into one another, creating eddies and whirlpools of breathtaking complexity. You see storms that are not mere storms, they are continent-sized vortices swirling with a power that could tear worlds apart. They are born, they rage for weeks or months, and they are reabsorbed into the planet's relentless flow, temporary brushstrokes on an eternal, moving canvas. And there, in the southern hemisphere, is the patriarch of all storms, the Great Red Spot. From here, it is not a spot. It is an abyss. A crimson eye staring out into the cosmos, unblinking and ancient. It is a hurricane so vast that 3 Earths could fit within its churning walls, a storm that has been raging for as long as we have had telescopes to see it, and likely for centuries before. It is a deep, angry ruby set within the paler bands of the planet, a permanent feature of this impossible world. You watch its slow, majestic rotation, a vortex of such profound age and power that it feels less like weather and more like a geological feature. It is a wound on the face of the planet that does not heal, a testament to the sheer, raw energy that drives this colossal machine. You feel a sense of serene insignificance. All the dramas of human history, all our triumphs and conflicts, are dwarfed by this single, silent, swirling storm. There is a deep philosophical comfort in this realization. Your own worries, the small anxieties that cling to the waking mind, seem to melt away in the face of such grandeur. You are simply an observer, a witness to a scale of reality that defies human ego. Your ship now settles into a wide, stable orbit, becoming another small moon in Jupiter's vast collection. From this new vantage point, you can observe the beautiful, intricate celestial mechanics of the system. You are now part of the dance. The Galilean moons are no longer distant sparks but vibrant, individual worlds, each on its own divinely simple path, their motions governed by the giant in the center. It is a perfect, cosmic clockwork, ticking off the eons in graceful, silent arcs. Closest to the great planet, you see Io. It is a world in constant agony, a place of torment and terrible beauty. Its surface is a mottled canvas of yellow, red, orange, and black, not from rock or ice, but from sulfur. It is the most volcanically active body in the solar system. Squeezed and stretched relentlessly by Jupiter's immense gravity, its insides are molten and it constantly vomits its fiery heart out into space. You watch from a safe distance as a plume of sulfur dioxide erupts from its surface hundreds of miles high, a ghostly, glowing umbrella that freezes into snow and falls back down to coat the ground. Io is a hellish flower, constantly blooming and dying, painting the space around Jupiter with a plasma torus, a faint, invisible ring of its own ionized breath. Further out you see Ganymede, the king's largest child. It is a world of contrasts, bigger than the planet Mercury. Parts of its surface are dark and ancient, pockmarked with craters from the solar system's violent youth. But great, sweeping lanes of brighter, younger ice cut across this old terrain, grooved and ridged as if a celestial rake has been dragged across the surface. It is a world that has a complex history written on its face, a story of old stillness and newer upheavals. It feels solid, majestic, a true prince in this royal court. Beyond it lies Callisto, the quiet, stoic sentinel. It is the most heavily cratered object we know, its face a frozen record of 4.5 billion years of impacts. It seems to have changed very little since its formation. It is a ghost of the early solar system, a dark, icy sphere that has passively endured the passage of time. There is a profound stillness about Callisto, a sense of deep, cold, undisturbed peace. It is the archivist of the system, preserving the memory of every ancient collision. And then your attention is drawn back towards the moon that shines with a smoother, more subtle light. Between the violent torment of Io and the grand scale of Ganymede, there is Europa. As you adjust your vessel's orbit, drawing closer to it, its character becomes clear. While the other moons display their history and violence openly, Europa is secretive. Its face is a pale, creamy white, crisscrossed by a fine, intricate network of reddish-brown lines. From a distance, it looks like a porcelain egg that has been gently cracked. There are very few craters here. Unlike Callisto's ancient, battered face, Europa's is young, smooth, constantly being resurfaced. It hints that this is not a dead, static world. It is alive in some way. Something is happening here, erasing the scars of time, wiping the slate clean. The lines that cross its surface are not random cracks. They are long, linear features, ridges and bands, some stretching for thousands of miles. They have a strange, almost organic geometry to them. They are like scars, yes, but scars that speak of healing, of movement, of a dynamic process happening just beneath the skin. This world, so serene on the outside, is hiding a powerful, active interior. Jupiter's chaotic beauty is on full display. Io's volcanic heart is worn on its sleeve. But Europa holds its secrets close. It whispers of a mystery, and as your ship gently alters its course, leaving the grand tour of the system behind, you feel yourself being pulled not just by gravity, but by a profound sense of curiosity. We are going to get a closer look at that beautiful, fractured face. We are going to try and read the story written in its icy scars. Section 3. A world etched in ice. Your vessel is a silent ghost gliding now in a low, intimate orbit. Jupiter is no longer the centerpiece, it is a colossal, silent guardian hanging in the black sky, its swirling bands a permanent, majestic backdrop to the world that now unfolds beneath you. Europa is no longer a globe, a sphere, a distant pearl. It has become a landscape, an endless, rolling territory of ice that stretches to a softly curving horizon. The scale has shifted from the astronomical to the geological, and the feeling is one of profound, solitary exploration. You are an eye in the sky, a single point of consciousness looking down upon a world that has never known a visitor. The first thing that strikes you is the light. It is a thin, silvery light from a sun that is now 5 times farther away than it is from Earth. It is a weak light, yet on the pristine, high-albedo surface of the ice, it is brilliant. The shadows it casts are long, sharp, and intensely black, creating a high-contrast world of dazzling white and absolute darkness. It is a landscape carved by light and shadow, and within this stark beauty, the details of the surface become breathtakingly clear. That initial impression of a cracked porcelain egg was only a sketch of the truth. Up close, the surface is a masterpiece of complex, fractured artistry. The dominant color is a brilliant, creamy white, the color of old, compacted snow. But it is not uniform. Woven through this white canvas is the intricate network of lines that you saw from a distance. Now you see they are not just lines. They are a deep, rich, reddish-brown, the color of rust or dried blood. They look like a vast circulatory system, veins and arteries running for thousands of miles, carrying some unknown, colorful lifeblood. Scientists back on Earth speculate that this color comes from salts and minerals, perhaps magnesium sulfate mixed with sulfur compounds spat out by the volcanic moon Io and irradiated by Jupiter's fierce magnetic field. But what you see is a world that is not sterile white, but stained. It is as if the ice itself is weeping, bringing up material from a hidden, darker, more complex place and blushing it across its frozen face. You drift lower, your gaze tracing these incredible features. They are known as lineae. Some are simple, fine cracks, like a hairline fracture in a china cup. But most are far more complex. You see vast, parallel ridges, sometimes 2, 3, or 4 running side by side, creating broad, raised highways across the ice plains. They look like sutures, as if the world has been torn open and then stitched back together by a clumsy giant. You can almost feel the titanic forces at play. You imagine the icy crust, miles thick, being pulled and stretched by Jupiter's gravity. You see it finally snapping under the strain, a crack racing across the surface for 1,000 miles in an instant of silent, cosmic violence. And then, from the wound below, a warmer, softer material, perhaps slushy, briny ice or even liquid water, wells up into the vacuum, freezing instantly and expanding, pushing the edges of the crack upwards to form these colossal, double-ridged scars. Each one is a frozen monument to a moment of immense stress and release. As you continue your silent traverse, you notice other features peppering the landscape like freckles. The scientists call them lenticulae. Some are domes, gentle swellings in the ice, as if something warm is pushing up from beneath, making the surface bulge. Others are shallow pits, places where the surface has perhaps sublimated away or collapsed into a void. And some are small patches of darker, jumbled terrain. You see them everywhere, these small, circular or elliptical anomalies. They give you the sense that the ice is not a solid, uniform slab. It is more like a pot of thick porridge on a low simmer. These lenticulae are the bubbles, the small disturbances, evidence of a slow, convective heat rising from the depths. They are bruises on the skin of the ice, hints of a restless energy far below. And then you drift over a region that makes you hold your breath. It is unlike anything else. It is a landscape of utter, bewildering chaos. They call it simply chaos terrain. It looks as if a section of the smooth, ridged plains hundreds of miles across was shattered into pieces with a great hammer. The ice has been broken into huge, angular blocks like rafts which have then drifted, tilted, and rotated before being flash-frozen back into place in a new, jumbled, nonsensical arrangement. It is a jigsaw puzzle that has been thrown into the air and then cemented solid before the pieces could land. You can see how one block, with its distinctive pattern of ridges, would have once fit perfectly against another 100 miles away. Between them now is a strange, lumpy matrix of new ice. What could possibly do this? The imagery is undeniable. This is what it would look like if a vast, solid crust was floating on a liquid layer below. A lake or an entire ocean. You imagine a huge section of the ice shelf melting from below, collapsing into the water beneath. The great plates of the surface crust become icebergs, floating and turning in a dark, slushy sea for to me a week, a century, a millennium, before the brutal cold of space freezes the surface of the water around them again, locking them into their new, chaotic configuration. These regions are the most powerful visual argument for a subterranean ocean. They are frozen snapshots of a cataclysm, a moment when the barrier between the solid world above and the liquid world below gave way. And in all of this, the long, weeping scars, the bulging domes, the shattered landscapes, you notice what is missing. Craters. On Earth's moon, or on Callisto, the surface is ancient and saturated with the circular wounds of impacts, a history book of cosmic bombardment. But here on Europa, they are hauntingly absent. You scan a region the size of a continent and see perhaps only one or two small, fresh-looking craters. This absence is as loud as a shout. It tells you that the surface of Europa is young. In cosmic terms, astonishingly young. Perhaps only 50 to 100 million years old, a mere blink of an eye in the life of the solar system. The craters that must have hit it, the constant rain of debris from space, are being erased. The ice shell is not a static, permanent record. It is a living, moving thing. It is like a conveyor belt with old ice being pulled down and new ice rising up. The lineae are the cracks from this movement, the chaos terrains are the catastrophic collapses, and the result is a constant renewal. The face of Europa is constantly being repainted, smoothed over, its blemishes removed. It is a skin that heals itself, and the energy for this healing must come from somewhere. The evidence is all here, etched into the ice. Every feature you observe is a signpost, a frozen arrow pointing down. Down through the miles of cold, brittle ice, towards the source of warmth, of movement, of mystery. Down towards the hidden sea. Section 4. Evidence of a secret sea. The frozen face of Europa tells a story. It is a story written in scars and chaos. A visual poem of stress, fracture, and renewal. Your eyes can trace the narrative. Your mind can infer the power of the forces that shaped this landscape. But seeing, as profound as it is, can only take you so far. The evidence etched in the ice is compelling, but it is circumstantial. It is like finding a wet footprint on a dusty floor. You are almost certain someone has passed by, but you did not see them. To truly know, to move from strong suspicion to near certainty, you must learn to perceive this world in ways beyond sight. You must listen for its hidden frequencies. Feel its invisible presence. You must use the senses of your vessel, the delicate instruments that can read the silent, subtle languages of the cosmos, the language of gravity and the language of magnetism. Let us begin with magnetism. Imagine for a moment the space around Jupiter. It is not empty. The planet, with its churning metallic hydrogen core, generates a magnetic field of almost unimaginable power and scale. It is a magnetosphere so vast that if it were visible to the naked eye from Earth, it would appear larger than our full moon. This is not a gentle field. It is a roaring, invisible storm of charged particles, a cosmic blizzard spinning with the planet's rapid rotation. Europa, in its constant orbit, is forever plowing through this tempest. It is perpetually bathed, soaked, and swept by powerful, shifting magnetic currents. Now, consider a simple law of physics. If you move a magnet past an electrical conductor, the moving magnetic field induces an electrical current within that conductor. The conductor, in turn, generates its own secondary magnetic field in response. It's a fundamental interaction, a call and response written into the fabric of the universe. When the Galileo spacecraft, our robotic predecessor in this system, flew past Europa again and again, its sensitive magnetometer listened. It listened to the conversation between Jupiter and its icy moon. If Europa were just a solid, inert ball of ice and rock, the magnetometer would have detected only one thing: the overwhelming, predictable magnetic field of Jupiter. But that is not what it found. As Galileo swept past, it detected a faint, but clear, distortion. A subtle ripple in Jupiter's field, a ghostly echo that was not coming from the giant planet. This faint field was centered on Europa itself. It was the moon's own magnetic signature. But it was a strange one. It wasn't a steady, self-generated field like Earth's, which comes from our own internal dynamo. Europa's field was fickle. It flipped its direction perfectly in sync with its location in Jupiter's magnetic storm. When Jupiter's field pointed one way, Europa's field responded in perfect opposition. It was a clear, unmistakable response to Jupiter's call. It was an induced magnetic field. The stunning implication of this discovery settled over the scientific community like a profound quiet. The call and response was happening. Europa was behaving exactly like an electrical conductor. But ice, especially the pure water ice thought to make up the crust, is a very poor conductor. Rock is not much better. For a signal this strong, this clear, and this perfectly global, there had to be a conductor on a planetary scale hidden inside the moon. There is only one plausible candidate, one material that fits the data perfectly: a vast, spherical shell of liquid salt water. The salts, the same kinds of mineral salts you might find in Earth's oceans dissolved in the water, make it electrically conductive. This subterranean sea, a global ocean wrapped around the moon's rocky mantle, becomes a planetary-scale electrical generator. As Jupiter's magnetic field sweeps through it, it creates enormous electrical currents that flow through the entire ocean, which in turn generates the faint, secondary magnetic field that Galileo detected. The discovery was the equivalent of tapping on a wall and hearing not a solid thud, but a deep, resonant splash from the other side. The visual story of the ice was now backed by the undeniable physics of the invisible. The ocean was real. But there is another thread of evidence, another invisible language that confirms the story: the language of gravity. As your vessel orbits Europa, you are not following a perfectly smooth, simple path. You are being pulled by the moon's own gravity. By tracking the motion of your spacecraft with exquisite, millimeter-per-second precision, you can create a map of that gravitational pull. And that map tells you how mass is distributed inside the moon. Is it a uniform ball of one material, or is it layered like a celestial onion? Your instruments listen to the gentle tugs and pulls on your orbit. The data streams back, a silent conversation between your ship and the heart of Europa. The answer becomes clear. Europa is not a uniform body. It is differentiated. The gravity data reveals a world built in distinct layers. At the very center, there is a dense core, most likely metallic, an iron heart much like Earth's. Wrapped around that core is a thick, rocky mantle, a sphere of silicate rock. And surrounding all of that is the final layer, an outer shell approximately 100 kilometers or 60 miles thick. The density of this outermost layer is the final, crucial clue. It is far too light to be solid rock. Its density is perfectly consistent with water. 100 kilometers of water. The visual evidence from the surface tells us the topmost layer is a solid ice crust. The gravity data tells us the entire outer layer, all 100 kilometers of it, is made of H2O. When you put these two facts together, the conclusion is inescapable. The outermost part of that layer is the frozen ice shell, perhaps 10 or 20 miles thick. But the remainder, the vast majority of that 100-kilometer depth, must be liquid. A global ocean, perhaps 80 kilometers deep, hidden beneath a ceiling of ice. For perspective, the deepest point in any ocean on Earth, the Mariana Trench, is only about 11 kilometers deep. Europa's hidden sea could be 7 or 8 times deeper, holding more than twice the amount of liquid water of all of Earth's oceans combined. The stories converge. The fractured, youthful face of the ice speaks of a dynamic layer beneath. the magnetic response sings of a global, salty conductor. The pull of gravity draws a blueprint of a layered world with a thick, outer shell of water. All the evidence, seen and unseen, points to the same breathtaking truth. You are orbiting not just a moon of ice, but an ocean world. A world of water wrapped in a thin, frozen shell adrift in the cold darkness of the outer solar system. A profound sense of wonder settles upon you. The mystery of if the ocean exists seems to have been solved. It is there, beneath your feet, a dark, silent, and unimaginably vast realm. But this resolution immediately gives birth to a new, even more fundamental question. Here, so far from the gentle warmth of the sun, in a place where the ambient temperature is hundreds of degrees below freezing, how can such an immense body of liquid water even exist? Where does the heat come from, the energy required to keep an ocean from freezing solid? The answer lies not within Europa itself, but in its relationship with the giant that holds it captive. Section 5. The Engine of Tidal Heat. The question hangs in the silent cabin of your vessel, as vast and profound as the view outside your window. Where does the heat come from? The sun, that distant, brilliant diamond, offers little comfort here. Its light is too weak, its warmth too diffuse to melt even a puddle on Europa's surface, let alone sustain a global ocean miles deep. The answer cannot be found by looking out at the cosmos, but by feeling the subtle, rhythmic forces acting upon your own ship and upon the very world beneath you. The answer is not light, it is motion. It is a dance, a relentless, gravitational waltz with the giant king, Jupiter. You feel it as a faint, almost imperceptible vibration, a deep, resonant hum that seems to emanate from the very structure of the moon. This is the source of Europa's warmth. It is the power of tides. When you think of tides on Earth, you picture the sea rising and falling on the shore, a gentle, daily rhythm pulled by the moon. But the tidal forces at play here are of a completely different order of magnitude. Jupiter is not our gentle moon. It is a behemoth, 318 times more massive than Earth. And Europa is not a distant observer. It is locked in a close, intimate orbit. The gravitational pull from Jupiter is colossal. It is so powerful that it deforms the very shape of Europa. The moon is not a perfect sphere. Jupiter's gravity stretches it, pulling it into a slightly oblong, egg-like shape, with one bulge pointing perpetually towards the giant planet and another pointing directly away. If Europa's orbit were a perfect circle, this bulge would be static. The moon would be tidally locked, always presenting the same face to Jupiter, and this stretched shape would be its permanent, frozen state. There would be stress, but no change, and therefore no heat. But Europa's orbit is not a perfect circle, and this small, crucial imperfection is the secret to everything. Look out again at the celestial clockwork. Observe Europa's neighbors, Io and Ganymede. As Europa glides along its path, it is rhythmically overtaken by the inner, faster-moving Io, and it, in turn, overtakes the outer, slower-moving Ganymede. Each time they pass, their own gravity gives Europa a little tug, a little nudge. These nudges are small compared to Jupiter's constant pull, but their timing is perfect, their effect cumulative. This cosmic resonance, a phenomenon called orbital resonance, prevents Europa's orbit from ever settling into a perfect circle. Instead, it is forced into a slightly eccentric elliptical path. This seemingly minor detail changes everything. It means that as Europa orbits Jupiter, its distance from the giant planet constantly changes. It moves a little closer, then a little farther away, in a steady, predictable rhythm. And as its distance changes, the strength of Jupiter's gravitational pull on it also changes. When Europa is closer, the pull is stronger, and the moon is stretched more. When it is farther away, the pull is weaker, and the moon relaxes back towards a more spherical shape. Now imagine this happening to the entire world beneath you. With every single orbit a period of just 3.5 Earth days, the entire moon is being squeezed and stretched, flexed, like a person rhythmically squeezing a rubber ball in their hand. This constant flexing generates an immense amount of friction within the moon's interior. The layers of ice and rock grind and rub against each other on a planetary scale. And friction, as we know, generates heat. This is the engine, tidal heating. It is a gentle, but utterly relentless, source of internal warmth, constantly kneading the moon's core and mantle. It is this internal fire, born not of sunlight or radioactive decay but of pure gravitational mechanics, that warms Europa from the inside out. It is this energy that has kept its vast ocean liquid for potentially billions of years, protected beneath an insulating shell of ice. You can almost feel the process. You imagine the rocky mantle deep below, being massaged by these tidal forces, warming up. This warmth radiates outwards, reaching the boundary where the rock meets the bottom of the global ocean. Here, at the seafloor, this heat creates a dynamic, vibrant environment. It may even be enough to drive volcanism, creating hydrothermal vents, great cracks in the seafloor spewing hot, mineral-rich water into the ocean above. This same heat then travels up through the liquid water of the ocean. The warmer water at the bottom of the sea will slowly rise, while the colder water near the ice ceiling will sink, creating vast, slow, convective currents within the ocean itself, a gentle, planet-wide churning that circulates heat and chemicals. And finally, this heat reaches the ice shell itself. It is this internal warmth that keeps the bottom of the ice from freezing solid, maintaining the boundary between liquid and solid. It is this heat that drives the geology you see on the surface. It softens the ice from below, making it pliable. It creates the pressure that forces water or slush up through the cracks, forming the lineae. It melts vast regions from beneath, creating the chaotic terrains. The entire, dynamic, youthful face of Europa is a direct expression of this tidal engine, a visual manifestation of the heat being churned out by its orbital dance. There is a beautiful, poetic quality to this. Europa is not just a passive object being acted upon. It is an active participant in its own story. It draws its lifeblood, its warmth, from its relationship with its giant companion and its siblings. It is a world kept alive by a celestial rhythm, a heartbeat timed to the beat of its own orbit. It is a testament to the fact that energy and warmth can arise in the most unexpected of ways, far from the familiar comfort of a star. You look down at the silent, frozen surface, but you no longer see it as just cold ice. You see it as a blanket, an insulating layer that traps the precious, tidally generated heat, protecting the vast, dark secret it holds. And you realize with a sense of mounting anticipation that it is time to go there. It is time to leave the realm of observation from above, to leave the light of the distant sun and the stars behind. It is time to begin the great descent, to plunge through this protective blanket of ice and enter the realm that has, until now, existed only in data, in theory, and in your imagination. It is time to visit the ocean itself. Section 6. The plunge into darkness. The time for inference is over. The data has been gathered. The stories from magnetism and gravity have been told. The surface, with its beautiful cryptic scars, has been mapped and memorized. From your orbiting perch, you have learned all you can. To understand a secret, you must eventually enter the room where it is kept. And so, a new phase of your journey begins. A new vessel awaits you. An extension of your consciousness designed for a singular, sacred purpose, to go down. It detaches from the main ship with a barely audible click, a final, metallic sigh of release. Your new craft, the Descender, is a teardrop of polished metal and reinforced crystal, a seed of technology built not for the vacuum of space, but for the crushing pressures of the deep. It is an instrument of immense strength, yet its purpose feels delicate, almost reverent. It falls away from the orbiter, which has been your home and your high vantage point, now appearing like a silver cross against the backdrop of the swirling giant, Jupiter. For a moment, you are in between worlds, no longer orbiting, not yet landed, a solitary thought drifting towards the ice. The descent is slow, powered by gentle thrusters that guide you towards a preselected landing city, a smooth, relatively unfractured plain. a place of apparent stability. As you get closer, the landscape resolves into fine detail. You see the texture of the ice, the subtle sparkles of crystalline structures, the fine dust of radiation-darkened minerals coating the surface like a faint sprinkle of cinnamon. Then, with a soft finality, you touch down. The gentle thrusters cut out, and a new kind of silence envelopes you. It is the silence of contact, the silence of a world without wind, without atmosphere, without any medium to carry sound. The only noises now are the ones you have brought with you. The low, steady hum of your life support, the quiet whir of internal systems. You have landed. And now the true plunge begins. There will be no drilling in the conventional sense, no brutal grinding of metal against ice. The method is more elegant, a union of heat and patience. From the nose of your craft, a ring of elements begins to glow, first a dull cherry red, then a brilliant, soft white. A halo of pure heat blooms against the frozen surface. The ice, which has known nothing but absolute cold for millennia, meets this impossible warmth. It doesn't shatter, it yields. With a silent, vaporous sigh, the surface layer sublimates directly into gas, which vents away into the thin vacuum. You are sinking. Your journey into the solid world has begun. You are descending into a well of your own making. The light from above, the silvery glint of the far-off sun. The reflected glow from Jupiter's immense facies funneled down your borehole. For the first few hundred feet, it is still bright. The walls of your tunnel are smooth, melted, and instantly refrozen into a perfect, glassy tube around you. You are a needle stitching yourself into the fabric of this moon. As you sink deeper, the character of the ice begins to change. The top layer, the first mile or so, is the brittle zone. This is the ice that feels the full, shocking cold of space. It is rigid, crystalline, and full of stress. Your forward sensors detect a web of fine fractures and cracks, ancient stresses frozen into the structure. You pass through layers of slightly darker ice, perhaps containing dust from meteorite impacts that happened thousands of years ago, a frozen record of cosmic history. The sounds, transmitted through the hull of your craft, are sharp and percussive pings and cracks as the thermal stress of your passage releases ancient tensions in the ice around you. But as you descend further, mile after mile, something remarkable happens. The immense pressure of the ice above you begins to change the very nature of the ice below. It is no longer brittle. It becomes ductile, plastic. It behaves less like a pane of glass and more like a river of frozen honey. The sharp cracks and fractures disappear, replaced by flowing, contorted patterns. You are now moving through ice that is slowly, imperceptibly, flowing and convecting, carrying heat from the deep interior up towards the surface in a geological timescale. The sounds change. The sharp pings are gone, replaced by a deep, resonant groaning, the sound of a world under immense, constant pressure. The light from the surface is long gone. You are in a realm of absolute blackness, pierced only by the beams of your own craft. Your lights illuminate a world that has never known light. They reveal the slow, beautiful, twisted shapes of the flowing ice, bands of clarity and opacity, a silent, frozen ballet. You pass through a trapped pocket of what your sensors read as a thick, briny slush, a frozen memory of the ocean below, captured on its journey upwards millions of years ago. You are a time traveler, descending not just through space, but through the geological history of this ice shell. The sense of isolation is profound. You are aware, with every passing moment, of the weight above you. Miles of solid world. The pressure is a number on a screen, a number that climbs relentlessly, but you can feel it in a more primal way. You feel the immensity of your solitude, a single point of warmth and life suspended in a universe of solid, crushing cold. The journey is slow. The passage of time is measured not in hours or days, but in meters of descent. Patience is your fuel. Then, after a journey that feels like an eternity, the instruments begin to report a change. The temperature at the front of your probe, which has been slowly rising for the last mile, begins to climb more rapidly. The density of the medium you are melting through starts to decrease. The groaning of the ice gives way to a softer, slushier sound. You are getting close. Your lights, once reflecting off hard, solid walls, now seem to be absorbed into a cloudy, indistinct boundary ahead. You are approaching the transition. The final barrier. The last 100 feet are not ice in the way you knew it. It is a thick, porous, chaotic layer of fragile ice and slush, the boundary zone where the solid world finally relinquishes its hold. Your probe pushes through it, a gentle, steady advance into a thickening fog. And then it happens. It is not a dramatic crash or a sudden explosion. It is a release. A silent, sudden freedom. The downward thrust of your melter is no longer needed. The groaning pressure ceases. Your craft, which had been fighting its way down, suddenly becomes buoyant, wanting to float up. You have punched through. You have arrived. You are floating. The engines are silent. The melter is off. There is only the faintest hum of your internal systems and the sound of your own quiet breath. You are in a place of absolute darkness, a blackness so complete and profound it feels like a physical substance. It is a primordial, virgin dark that has not been touched by a single photon in 1 billion years. Your external lights switch on, cutting a cone of pure white into the void. And what you see is water. But it is not empty. Drifting slowly, serenely, through the beam of your light is a constant, gentle blizzard. A slow-motion cascade of tiny, translucent particles. Marine snow. Fragments of ice, mineral grains, perhaps clumps of organic molecules, all slowly raining down from the ice ceiling far above on a journey to the seafloor miles below. It is the slow, gentle rain of a world without a sky, the first sign that this is not a sterile, static pool of water. It is a system. It is an environment. A process is at work here. You have left the world of light and sky and ice behind. You are suspended in the heart of the mystery, floating in an alien ocean, wrapped in a silence and a darkness that is older than humanity itself. The journey down is over. The exploration of this hidden sea has just begun. Section 7. A recipe for life. You float in the stillness, a solitary beacon in an eternal night. The gentle blizzard of marine snow drifts around your craft, each particle a silent question. The sheer fact of this place is overwhelming, a liquid ocean, vast and ancient, hidden from the cosmos. The question of how it exists has been answered by the elegant physics of tidal heating. But now, suspended within the answer, a far more profound question takes its place, a question that whispers from the very depths of the water around you. Is it merely an ocean? Or is it an abode? Could there be life here? To answer this, you must think not as an engineer or an explorer, but as a chemist, a biologist. You must consider the fundamental ingredients, the essential recipe that life, as we understand it, requires. On Earth, this recipe is remarkably simple, distilled down to 3 core concepts. Liquid water, a source of energy, and the right chemical building blocks. You are floating in the first ingredient, in quantities that defy imagination. The second, energy, is being pumped into this ocean constantly by the tidal friction from Jupiter. But what about the third? What about the chemistry? Your vessel is not just a submersible, it is a floating laboratory. As you begin a slow, controlled descent away from the ice ceiling and into the deeper ocean, your external sensors begin to taste the water. They are a network of sophisticated tongues, sampling this alien sea, analyzing its composition, searching for the subtle flavors of possibility. The first readings confirm what the magnetic field data suggested long ago. The water is salty, but the profile is not quite like Earth's. Alongside familiar sodium chloride, your instruments detect sulfatous magnesium and sodium sulfates. This gives the water a slightly different chemical character, perhaps a bit more bitter in a chemical sense. But for life, the presence of salts is crucial. They lower the freezing point of water, helping to keep the ocean liquid. They also play a vital role in biological processes, helping to regulate cells and conduct nerve impulses. The saltiness is a good sign. It makes the ocean more stable, more dynamic. You continue to sink. The pressure increases with every meter, a steady, crushing force that would obliterate any lesser craft. But your descender is built for this, its hull resisting the immense weight of the water column above. You are sinking deeper into the heart of Europa. The gentle snow from the ice ceiling becomes thinner, the water clearer, blacker. Your lights now pierce deeper into the void, revealing nothing but the profound emptiness of the mid-ocean. Your instruments continue their silent work, sipping at the water. They search for the building blocks of life. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. The CHNOPS elements, the fundamental atoms from which all known life is constructed. Oxygen and hydrogen are here in abundance in the water molecules themselves. But what about the others? The answer comes from two directions, from above and from below. Look up, back towards the ice ceiling you left behind. Remember the surface, perpetually bombarded by Jupiter's intense radiation. This radiation is not just a destructive force. It is a creative one. It smashes into the water ice, H2O, on the surface, splitting the molecules apart. The hydrogen, being light, can escape into space, but the oxygen is left behind. This oxygen, a highly reactive element, can then combine with other trace elements in the ice or with itself to form potent oxidant compounds like oxygen, O2, and hydrogen peroxide, H2O2. The constant churning of the ice shell, the process of subduction and renewal that erases craters, can act as a conveyor belt. It can carry these oxygen-rich compounds from the irradiated surface down through the ice and deliver them directly into the top of the ocean. The surface, bathed in radiation, becomes a factory for one of life's most powerful fuels. Now think of what is below you. Miles down at the very bottom of this ocean lies the rocky mantle. The tidal heating that warms this entire moon is not distributed evenly. It is most intense deep inside. The seafloor is almost certainly not a cold, dead, static place. It is a boundary, a place of immense chemical exchange. Just like on Earth, water percolates into the hot rock, dissolving minerals, becoming enriched with chemicals. The heat from tidal friction likely drives hydrothermal activity. You can almost picture it, great fissures in the seafloors, cracks in the rock where superheated, mineral-rich water is jetting out into the cold ocean, creating towering, chimney-like structures of precipitated minerals. These vents, if they exist, would be a chemical paradise. They would be spewing a rich soup of dissolved minerals and gases from the moon's interior into the water. They would release compounds like hydrogen sulfide, methane, and ammonia. These are reductants, electron-rich chemicals, the perfect counterparts to the oxidants raining down from the surface. And here, in this simple concept, lies the magic. You have oxidants coming from the ceiling and reductants coming from the floor. When these two types of chemicals meet, they can react. This reaction releases energy. It is a chemical reaction, a flow of electrons from one molecule to another that a living organism could harness. It is a planetary scale battery. The ice ceiling is the positive terminal, the seafloor is the negative terminal, and the entire ocean is the electrolyte that connects them. The energy for life here would not come from the sun through photosynthesis. It would come from pure chemistry through chemosynthesis. Your sensors ping with a new reading, a trace of carbon. Not much, but it's there. It could have been delivered by comets and asteroids, remnants of the solar system's formation, rich in organic molecules that have impacted the surface over eons and been churned down into the ocean. Or it could be carbon dioxide seeping out from the rocky mantle below. Whatever its source, it is the most crucial ingredient of all. Carbon is the backbone of life, the versatile atom that can form the long, complex chains of proteins and DNA. The recipe is complete. You have the liquid water. You have the chemical building blocks, the CHNOPS elements, delivered from the ice above and the rock below. And you have a powerful source of energy, a chemical gradient, a planetary battery formed by the separation of oxidants and reductants. All the ingredients are here, simmering together in this dark, pressurized, ancient pot. It is a recipe that has been slowly cooking for billions of years. A profound sense of awe settles over you. This is no longer a sterile geological curiosity. It is a plausible, compelling habitat. The conditions are met. The potential is undeniable. This ocean is not just a body of water. It is a chemical engine, perfectly configured to potentially support life. The question is no longer, could life exist here? The question has become far more personal, far more immediate, as you sink ever deeper into the darkness toward the seafloor. The question is it here now? You are no longer just a chemist. You are a seeker, and your lights are now probes, searching the darkness not just for minerals and chemicals, but for any sign of movement, any hint of structure, any shadow that does not belong. The ultimate search has begun. Section 8. Earth's Deep Sea Parallels. The cone of your light cuts through the abyssal blackness, a solitary question mark in the deep. You are searching for life, but what, in a place like this, would life even look like? Without a sun, without plants, without any of the familiar anchors of biology, the imagination can feel untethered, lost in a sea of infinite and improbable forms. How can you search for something you cannot first imagine? And so, to find a map for this alien territory, let us perform a gentle trick of the mind. Let us leave this place for just a moment. Let your consciousness travel back across the hundreds of millions of miles, back through the asteroid belt, past the red ember of Mars, and home to the warm, blue embrace of Earth. Let us dive not into Europa's ocean, but into our own, down into the deepest, darkest, most secret corners of our own planet. Because we, too, have a hidden world of life that exists in eternal night. A world that was, until very recently, as alien to us as the one you are in now. For most of human history, we believed a simple, fundamental truth: all life on Earth ultimately depends on the sun. Photosynthesis was the foundation of everything. Plants and plankton captured sunlight, and everything else ate them or ate the things that ate them. The sun was the single engine of biology. So it was assumed that the deep ocean floor, a place of total darkness, crushing pressure, and near-freezing cold, must be a barren desert, populated only by the scant few scavengers who could survive on the meager scraps that drifted down from the sunlit world above. Then, in the year 1977, a human-crewed submersible not so different in spirit from your own descender was exploring a mid-ocean ridge near the Galapagos Islands. They were looking for geological evidence of seafloor spreading, for hot springs they theorized must exist. What they found shattered our understanding of life forever. Imagine their view. Out of the utter blackness, their lights fell upon a scene of impossible vibrancy. They found towering, chimney-like structures, some a dozen stories high, built from precipitated minerals. From the tops of these dark spires, a thick, black smoke of superheated, sulfur-rich water was billowing out like the chimneys of a phantom factory on the ocean floor. And all around these vents, these black smokers, was an oasis. An ecosystem teeming with life, packed together with a density that rivaled a tropical rainforest. It was a garden of flesh and shell in a world without light. There were giant tube worms, 6 feet long, with no mouth and no gut, their bodies encased in white chitinous tubes crowned with brilliant, blood-red plumes that swayed in the chemical currents. There were fields of ghostly white crabs scuttling over the rocks and swarms of pale, blind shrimp clustering so densely around the hot vents that they seemed to shimmer. There were ghostly fish, strange clams, and mussels, all thriving in water laced with chemicals that would be toxic to surface life. None of it made sense. How could they live? The answer was a revelation that echoes through your own journey now. They were not living off the sun. They were living off the heat and chemistry of the earth itself. At the very bottom of this food chain were bacteria. But these were not ordinary bacteria. They were chemosynthetic. They did not eat or photosynthesize. They performed a kind of microbial alchemy. They ate the poisonous hydrogen sulfide gushing from the vents, a chemical rich in energy, and used it to create organic matter, just as a plant uses sunlight. These bacteria were the foundation of everything. They were the sun for this ecosystem. They grew in thick, slimy mats on the rocks or lived symbiotically inside the bodies of the tube worms and clams, feeding them from within. The shrimp and crabs grazed on the bacterial gnats. The fish preyed on the shrimp. a complex, vibrant food web built entirely on chemical energy drawn from the planet's own inner fire. They were, in a very real sense, aliens on our own planet. Their existence proved that life did not need the sun. It just needed a chemical imbalance and a medium like water. Now bring your consciousness back to your descender, sinking through the silent European Sea. The memory of Earth's deep oases is now a part of you, a template in your mind. The impossible has become plausible. The search is no longer blind. As you continue your descent, your instruments begin to sing a new song. The ambient temperature of the water, for so long a steady, near-freezing cold, begins to tick upward by a few degrees. Your chemical sensors, the tongues of your craft, report a rising concentration of sulfates, sulfides, and perhaps methane, the very ingredients for a chemosynthetic feast. You are approaching a source of heat and chemistry. You are approaching a European vent. You no longer look into the darkness with simple awe, but with focused expectation. You know what you are looking for, not for green things with leaves, but for life born of chemistry. Perhaps there are mats of alien microbes, clinging to the rocks, their colors not green, but perhaps a deep purple or a rusty orange, depending on the minerals they metabolize. Perhaps there are strange, gelatinous structures that filter the water, feeding on these microbes. Perhaps there are slow-moving, armored grazers, or even swift, ghostly predators that navigate by sensing the chemical trails and faint electrical fields of their prey. The forms would be different, the biology utterly alien, but the principle would be the same as the one we discovered in our own backyard. Life huddled around a source of planetary warmth, drawing its energy from the rock below, not the star above. The seafloor is getting closer. Your sonar begins to paint a picture of the terrain ahead. It is not a flat, muddy plain. It is jagged, mountainous, a landscape of volcanic rock. And in the center of your view, a cluster of tall, spire-like formations is beginning to resolve from the data. The temperature is still rising. The chemical soup is getting thicker. You are a few hundred meters away. You dim your main forward lights, preparing your sensitive cameras, not wanting to startle a world that has only ever known darkness. You are approaching the very place where the recipe for life, water, chemicals, and energize at its most potent. You are approaching a potential garden in the deepest, darkest cellar of our solar system. Section 9. Listening for a heartbeat. The final few hundred meters of your descent are the most profound. Every system on your craft is now a sense organ, strained to its limit, listening, feeling, and watching. The sonar paints a ghostly, acoustic image of the terrain ahead, a field of jagged spires confirming the presence of what must be hydrothermal vents. The temperature gauges climb steadily, a clear sign of geothermal warmth. The chemical sniffers are alive with the scent of sulfur and minerals. All the signs point to this being the Placia nexus of energy and chemistry, a potential cradle for life. Your external lights are dimmed to a soft, exploratory glow, just enough to see by without being intrusive. You are a guest here, a visitor to a world that does not know it has won. The seafloor finally resolves itself into a visible landscape. It is a scene of stark, dark beauty. The ground is a fine, silty sediment, the accumulation of eons of marine snow raining down from the ice ceiling. Out of this dark dust rise the chimneys. They are not black like the smokers on Earth, but a pale, almost white color likely formed from precipitated sulfate salts and silica. They are twisted, gnarled structures reaching up into the dark water like the petrified fingers of sleeping giants. From the tops of some, you can see a shimmering distortion in the water. It is not smoke, but a clear, superheated fluid, mixing with the frigid ambient seawater, creating visible, refractive currents. This is the lifeblood of the system, the warm, chemical-rich fluid from the mantle being pumped into the ocean. You guide your descender closer to one of these active spires, your movements slow and deliberate. Your high-resolution cameras scan every inch of the chimney's surface. Your lights sweep across the rock. You are searching for something, anything, a texture that is not rock. a movement that is not the current, pattern that is not random. You look for the telltale sheen of a microbial mat, the slime of life. You search for any structure, no matter how small or simple, that has the organized complexity of a living thing. Your spotlights catch something. A patch on the side of the pale chimney with a different hue, a rusty orange stain. Could be a simple mineral deposit. Or it could be a colony of microorganisms, their bodies rich in iron compounds, a biological rust. You maneuver the craft's sampling arm, a delicate, precise instrument, and with the utmost care, you touch it to the surface. A tiny sample is scraped away and drawn into a secure analysis chamber within your vessel. Inside, a miniature laboratory will sequence any shred of complex organic material it finds, looking for the unmistakable signature of DNA or some other information-bearing molecule. It will look for life's fingerprint. You continue to explore. You drift between the pale towers, a silent ghost in this underwater forest of stone. The sheer potential of this place is a palpable force. The conditions are so perfect, the recipe so complete, that the absence of life would be almost as shocking as its presence. Every shadow holds a world of possibility. Is that strange, bulbous shape a rock, or a sessile creature, patiently waiting for a meal to drift by? Is that flicker of movement a particle in the current, or a free-swimming organism, darting away from your light? This is the great challenge, the search for definitive proof, and it highlights the limitations of a single robotic explorer. The question of life on Europa may not be answered by a single photograph or a single sample. It may require years of patient observation, of mapping these oases, of understanding the complex interplay of their geology and chemistry. And so, let us gently pull our focus away from the immediate, tantalizing view from the descender. Let us zoom out, back to our own time, back to the world of human endeavor that is preparing for the next great steps in this search. For this journey you are on is a journey of the imagination, but it is one that is inspiring a real, tangible future of exploration. On the drawing boards and in the clean rooms of NASA and other space agencies, a new generation of explorers is being built. The flagship of this new fleet is a mission called the Europa Clipper. It is not a lander or a submersible. It is a sophisticated orbiter designed to be the ultimate reconnaissance scout. It will not fly to Europa and stay in one orbit. That would be too dangerous, exposing it to the full, lethal fury of Jupiter's radiation belts. Instead, it will perform a series of dozens of high-speed, low-altitude flybys. It will swoop in close, gathering immense amounts of data and then swing back out to a safer distance. The Clipper will be a sensory masterpiece. It will carry a powerful ice-penetrating radar, an instrument designed to do from orbit what you have done in your imagination. To measure the thickness of the ice shell and confirm the depth and salinity of the ocean beneath it. It will have high-resolution cameras to map the surface in breathtaking new detail, helping scientists to identify potential landing sites for future missions. It will carry thermal imagers to look for hot spots, places where the ice is thin and the ocean's warmth is close to the surface. And it will have advanced spectrometers to analyze the chemical composition of the mysterious reddish-brown material in the lineae, to see if it contains the chemical signatures of life. Perhaps most excitingly, the Clipper will fly through the plumes. Observations from telescopes like Hubble have suggested that Europa, like Saturn's moon Enceladus, may be actively venting plumes of water vapor from its ocean out into space. If these plumes are real, the Clipper could fly directly through them, sampling the ocean's material without ever having to land. It could taste the ocean from 100 miles up, analyzing the spray for salts, for organic molecules, for the very building blocks of life. It would be like listening for a world's heartbeat by catching its breath. The Europa Clipper is the next logical, patient step. It is the mission that will turn the strong evidence we have now into a high-resolution map of possibility. It will tell us where to go. It will tell us how deep we need to drill. It It will be the scout that paves the way for the future landers and submersibles, the descendants of your imaginary craft, that will one day take the final plunge and provide the definitive answer. Your journey in the Descender is a glimpse into that ultimate future. But the work of listening, of gathering clues, of patiently building our understanding from afar is already underway. We are at the very beginning of a new chapter in our search for life, a chapter that is moving its focus from the dry, dusty plains of Mars to the deep, dark oceans of the outer solar system. We are learning to listen for a different kind of life, one that whispers in chemistry and heat, far from any sun. Section 10. A Cosmos of Hidden Oceans. The sample is secure. The data is collected. The first tentative touches upon a secret world have been made. It is time to return. With a final, lingering look at the pale, silent spires of the seafloor, your Descender begins its ascent. It is a slow, methodical journey back towards the distant ceiling of ice, a retreat from the realm of crushing pressure and profound darkness. As you rise through the endless water column, the vehicle retraces its path, a single point of light dwindling in the immense black. The world of the vents, with all its tantalizing possibilities, recedes into the depths, becoming once again a place of theory and of dreams. The journey upwards is one of contemplation. The mission to this single moon has been a universe of discovery in itself. But now, as you approach the ice shell once more, your perspective begins to widen. You begin to see Europa not as a singular anomaly, but as a member of a family. A representative of a new class of world that we are only just beginning to comprehend. The ocean world. For so long, our search for life was governed by the concept of the habitable zone, a narrow, temperate band around a star where liquid water could exist on a planet's surface. We looked for other Earths, planets with atmospheres and oceans basking in the light of their sun. It was a reasonable place to start a search for the familiar. Mars, with its ancient, dried-up riverbeds, was the logical first candidate in our own system. But Europa shatters this paradigm. It teaches us a profound lesson. A world doesn't need to be in the habitable zone to be habitable. It just needs an alternative source of energy. Tidal heating, the gravitational dance with a giant planet, creates a new kind of habitable zone, one that is internal, not external. It creates a habitable ocean independent of the sun. And once you realize this, you start seeing them everywhere. Let us pull our focus back further. Your Descender docks with the orbiter, your primary vessel, which has been waiting patiently, a loyal guardian. From this high vantage point, you look out once more at the family of Jupiter. You see Ganymede. Its surface is older, more cratered, but it too shows signs of past resurfacing. Gravity and magnetic data strongly suggest that Ganymede, the largest moon in the solar system, may also harbor a hidden ocean, perhaps multiple oceans stacked between layers of high-pressure ice, a celestial club sandwich of water and frost. And even distant Callisto, the quiet, ancient one, may have a layer of salty slush deep within its interior. Jupiter's court is not one king and three rocks, it is a court of water worlds. Now let us journey further out. Let us leave the majestic realm of Jupiter behind and travel to the next great kingdom of our solar system, the realm of the ringed planet, Saturn. Here we find another moon, tiny and brilliant white, named Enceladus. It is a snowball of a world barely 300 miles across. But from its south pole, great, continuous plumes of water ice and vapor erupt into space like a planetary geyser that never stops. The Cassini spacecraft flew through these plumes, tasting them, and found salt, silica dust, and complex organic molecules. The evidence is undeniable. Tiny Enceladus has a global, liquid saltwater ocean and its floor is hydrothermally active. It is actively advertising its habitability to the cosmos. And Saturn's largest moon, Titan, the only moon with a thick atmosphere, has rivers, lakes, and seas of liquid methane on its surface, but models strongly suggest a vast ocean of liquid water lies deep beneath its exotic, hydrocarbon crust. The outer solar system is not a frozen, dead expanse. It is an archipelago of ocean worlds. We have gone from thinking Earth was the only water world to realizing that oceans are common, perhaps even ubiquitous, hiding beneath shells of ice. And if they are this common in our own solar system, What about the countless star systems beyond our own? We are discovering exoplanets by the thousands. How many of them are gas giants with their own families of icy moons, all being tidally kneaded, all hiding their own secret seas? The number could be staggering. The cosmos could be teeming with Europas and Enceladases. This realization is one of the most transformative in the history of science. It is a quiet revolution in our search for our place in the universe. It means that the most common habitats for life in the galaxy may not be worlds like Earth at all. They may be sunless oceans hidden away in eternal darkness powered by gravitational friction. Life may not be a rare phenomenon clinging to the sunlit surfaces of rocky worlds, but a common one thriving in the deep, dark, watery interiors of icy moons. Your journey to Europa was a journey to a single place, but it has unlocked a vision of the entire cosmos. It has expanded the very definition of world. It reminds us that secrets and wonders can be hidden in the most unassuming of places. That a placid, pale, icy moon can conceal a sea more voluminous than all of Earth's oceans combined. That the conditions for life are not limited to our own narrow experience, but are written into the fundamental laws of physics and chemistry, ready to blossom in the dark as well as in the light. The great mystery of whether Europa's ocean contains life remains. Your single sample, now being analyzed in the sterile quiet of your ship's lab, may hold the first clue, or it may be inconclusive. The ultimate answer may take generations of exploration. But the possibility, the sheer, breathtaking plausibility of it all has changed you. It has filled you with a profound sense of hope and wonder. You are no longer just an explorer of a single moon. You are an emissary from a sunlit world to the vast, hidden worlds of the dark. You have journeyed to the shore of a cosmic ocean and dipped a single, tentative toe in its waters. And you return with the humbling, exhilarating knowledge that our universe is far stranger, more creative, and more full of potential than we ever dared to imagine. The search for life is not just about looking out, but also about looking in. As our journey comes to a soft, quiet end, allow the sense of wonder to remain. Let it be a gentle anchor for your dreams. The universe is vast, and its most beautiful secrets are often the most deeply hidden. Perhaps, even now, in an ocean of eternal night, a billion miles away, something is stirring. But for tonight, your own journey is to the warm, peaceful depths of your own sleep. Let the questions fade, and let the gentle darkness embrace you. Sleep well and dream of hidden oceans.